Hi everyone, our next topic to discuss is periodization of training, or more specifically, periodization of resistance training. Now, the ability of strength and conditioning professionals to stimulate the physiological adaptations that are necessary to enhance performance is largely related to modulating the training stressors to enhance adaptive processes, while simultaneously reducing the potential for plateaus in performance or overtraining. Ultimately, as athletes become more trained, it becomes more difficult to stimulate performance gains. Thus, increased variation is often required in the training program of more advanced athletes in order to facilitate long-term training and performance gains. Now, to meet this requirement, training programs need to be logically designed so that they are structured in a systematic and pre-planned manner, allowing variation in training volume, intensity, frequency, mode, as well as exercise selection in accordance with the athlete's needs and the sport's requirements. So central to the effective programming of training interventions is the concept of periodization. Now, periodization is simply a systematic, pre-planned process of changing one or more variables in the training program over time. More simply put, it's planned manipulation of the acute program variables. So, through this process of periodization, of changing one or more variables in the training program over time, that's going to be necessary in order to stimulate adaptations that are necessary to enhance performance. These could include muscular as well as neural adaptations, or in terms of aerobic exercise athletes, it could be cardiovascular adaptations. Also, through this process of periodization, changing one or more variables in the training program over time, we're utilizing this process to achieve peak performance at appropriate time points, and finally to reduce the potential for performance plateaus, injury, or a syndrome known as overtraining occurring. And we'll talk about overtraining in a later slide. So, classic or linear periodization. This is a model in which gradual progressive increases in intensity over time occur. So with the linear periodization model, typically the athlete would start with a high initial training volume at a low intensity, and over time volume decreases as intensity gradually increases. And typically with linear periodization, the same sets and reps are performed across training days, but the load is varied across training days. Now, an alternative model that's termed daily undulating or non-linear periodization involves large daily fluctuations in the load and volume of assigned core resistance exercises. For example, using this model, you might perform 4 sets with a 6 RM load, more of a strength focus on the first day of the week, 3 sets with a 10 RM load, again more of a hypertrophic focus on the next training day, and then finally on the last training day of the week, performing 5 sets with a 3 RM load, more of a focus on power. Now, these modifications are in contrast to what occurs with the linear periodization model, in which the athlete performs the same number of sets and reps across the training days, but varying the training load. Now, some research, and we'll look at some of this research later on in this module, but some research studies suggest that the undulating model is more effective than the linear approach in terms of increasing muscular strength, although other evidence suggests no difference between the models, or that the linear model is superior. So let's look at one study, and this is a study that I was directly involved in as a graduate student at the University of Connecticut. And this study was performed to directly compare the impact of 2 isocaloric protein sources differing in protein quality on body composition responses to resistance training. So we're not going to focus on the different protein sources here. We're going to focus more on the resistance training program that was used in the study. So just a little bit about the study. We recruited young, untrained adults, and we had them supplement daily with either isocaloric whey protein, soy protein, or a carbohydrate beverage for 9 months. And all subjects performed supervised progressive whole body resistance training for 9 months. They completed resistance exercise 3 days per week and had to complete a total of 96 workouts to be included in the post-testing analysis. So this is an example of a 12-week mesocycle that we use in this study, and I'll define mesocycle later on. This mesocycle example shows variations in intensity with an emphasis on gains in muscular strength and lean tissue mass. So for this example here, over this course of the 12 weeks, again alternating light, moderate, heavy, and power days within a given week. So for week 1, for example, they may perform a immediate or moderate day of resistance training that would consist of 8 to 10 reps at a moderate load as well as shorter rest periods. The heavier day may be performed on day 2, consisting on fewer reps, a heavier load, and longer rest periods. And then the light days would be interspersed as well, consisting of more reps, about 12 to 15 reps per set, at a lighter load and short rest periods. And then occasionally we would also throw in some power days, which consisted of whole body exercises using about 30 to 45% of the estimated 1 RM to train maximal power. So you can see some of the exercises that we included here in our training program. Again, it was a whole body resistance training program performed for 9 months. We used what we called a flexible nonlinear approach or model. Therefore, if we decided that a participant was not ready to perform a high quality workout for a given day, such as a heavy day, this was based upon observed performance of the first exercise sets, then the trainer who supervised the workout would default to a light day or even a rest day in some cases, and then make up that workout at another time in the week. And we thought this was optimal in that it allows for optimal training and can allow for unanticipated but inevitable events that occur with long-term training. So again, we recruited basically healthy college students, both men and women. We had approximately 20 to 22 per group that we completed over the 9 months. You can see their characteristics up here, including their 1 RM squat and bench press. And then as expected with resistance training, in all 3 of the groups here, there was a significant and similar increase in 1 RM bench press and the 1 RM squat. So we see here the change in 1 RM squat and the change in 1 RM bench press at 3, 6, and 9 months. All of these increases here were significant, but no differences between the 3 different supplement groups. We also looked at lean body mass measured via DEXA. And what we found here, again looking at change scores at 3, 6, and 9 months, significant increases in lean body mass compared to baseline at 3, 6, and 9 months. However, we did see significantly greater increases in lean body mass in the whey versus the carb and the soy groups. So this is in kilograms here, and just for your reference, I put the range here of gains in lean body mass in pounds. Looking at the individual subject responses here, looking at changes in lean body mass, this is at 9 months compared to baseline, showing that resistance training was effective in the majority of individuals in increasing their lean body mass over time. So a recent systematic review of 17 studies, including a total of 510 participants, concluded that there was no significant differences in the effectiveness of linear versus undulating periodization on upper body or lower body strength gains with resistance training. So these results suggest that novelty or training variety are important for stimulating further strength gains. And it's important to note that strength and conditioning professionals are advised to design periodized training programs taking into account the resistance training principle of variety to prevent stagnation and accommodation to particular training approach.